Hello and welcome to Channels, the Nextflow podcast. You're listening to episode 30, going out on February the 6th of 2024. And today we've got a cracking episode lined up for you. On the show, we've got Paolo and Jordi from Seqera, and we're going to be talking to you all about the Fusion file system. Exciting stuff. My name is Phil Yules. I'm a product manager for open source software at Seqera, and I'm coming to you from Stockholm and in sunny Sweden. Paolo, do you want to quickly introduce yourself to anyone who's not met you before on this podcast?
Yeah, okay. I'm Paolo Di Tomasso. I'm software engineer, creator of Nextflow, and also CTO of Seqera Labs. Very quickly, I'm based in Barcelona.
Welcome. And Jordi?
Hi, I'm Jordi. I'm the first time in this podcast. I'm very happy. And I'm a software engineer in Seqera that I'm in charge of the Fusion file system.
I'm pulling all the secret strings. I think you're one of the dark horses of Seqera, Jordi. It's great to get you on the podcast. I've been wanting to invite you here for a while. So, episode all about Fusion. I mentioned Fusion in the last episode of the podcast. It's come up kind of a few times in passing over the last kind of year. We've never focused a whole episode on it, and I thought actually, it is quite an interesting topic. There's a lot of cool stuff going on here and quite a lot of complicated things where it's difficult to kind of cover it in a sentence here or there. So it's nice to do a bit more of a technical deep dive on what Fusion is, why it's useful and how it does that stuff. Before we get into
Fusion, why we need it.
And why we need it, exactly. Yeah. The why is always the most interesting. So Paolo, kick us off with that. So tell us about how Nextflow works with kind of object storage. Like, we've got a work directory, we've got staging, publishing. What's going on when we're not using Fusion just normally? If I'm running Nextflow,
even before, even apart on Nextflow, we started with the problem that data pipeline, life science pipeline. We have two major challenges. One is about computing. So we have large data that we need to, large computation we need to carry out in an efficient manner. But let's say for compute, we have plenty of solutions. HPC batch scheduler, cloud batch scheduler, Kubernetes. There are a lot of options that allow you to scale your pipeline execution. But into this application, another major bottleneck is storage, because this pipeline ingests enormous data set, produce enormous scratch temporary data, and final result terabyte for run. So one major problem is not just to optimize the computation. Another big challenges that we have into this field is to optimize the storage, because if you don't have an optimal way to ingest it, to store this data, retrieve the data in an efficient manner, you are just wasting computing. And then came into Nextflow. Nextflow has this idea to implement portable execution of your pipeline so that you can run many different cloud platform or on-prem computing platform, and other provide abstraction for the compute, provide abstraction for the storage, so that you can reference a file that is on S3, that is on Google Storage, or maybe in the local file system, shared file system, just changing the scheme in the file name. The problem that there are many different ways, depending the storage that you are using, change the way Nextflow handle this file, how is processed this file. So we back finally to your question: what happened behind the scene when we Nextflow try to access a file or stream? Well, this depends because if you are running Nextflow locally, your computer on HPC, and you have the data into an S3 bucket, what Nextflow is doing basically is just copying the file your computer and then running with the local executor or SLAR or HPC batch scheduler executor that is always using a local file system or shared file system. In any case, you need to transfer this file from remote bucket locally, and Nextflow, the Nextflow runtime is doing this. And this is actually is not efficient because, like we said, this data takes gigabyte, terabyte storage, so can be slow. It's not the optimal way to do that. This is why, yeah.
And this is a lot of network traffic that's happening at the start and end of every task. Basically, we're downloading the files, running it, and uploading them the results.
Can make sense for small data set, or just small data set when you use this pattern. But if you have large input data set, make much more sense to run Nextflow into a cloud compute environment where the data is. So if you have data in S3, much better to use AWS batch in the same region, and also use S3 as a scratch temporary directory path or storage where Nextflow creates stuff, because doing this, using this approach, the data transfer is not managed anymore by Nextflow, but is the task itself. They pull the data from the bucket into the container that is carrying out the computation. So much better, but still not optimal. I will say later why.
So to clarify the difference there, before you have this magic function of Nextflow, which I think also people love when they come to Nextflow and they discover that they can supply a file just with an HTTP prefix or an S3 prefix, and Nextflow just magically works and understands it. So before Nextflow would download that file and then run the task, and you're saying if you're running on AWS locally, it's better to let the task handle it directly. How do you mean? How is that different?
It's different that in the first case, when the data is in the object storage and Nextflow is running your computer on HPC outside the cloud, let's say, Nextflow need to transfer this. This can be parallelized, but still you need to create a copy all this stuff into your local computer and then carry out the computation. Especially when you have 1,000 tasks and 1,000 input files, just put a lot of pressure into the Nextflow driver application that carry out also the pipeline execution, because there is a huge bottleneck that create to transfer all this file for input, quite surely also for produce the output. So the head job running the pipeline become a bottleneck for the scalability of the pipeline. So that the model where all the stuff run into the cloud, the job itself pull the data and create a copy into the container. So more scalable because the data transfer is delegated to the job, but still is not optimal because you need to imagine a very basic approach into this case in which the job at the beginning just doing the download all the data using AWS 3 command line tool. So it's a stop the word phase, how to say. You're not using the compute power or the compute capability to carry out the job execution, but just to prefetch all the data in the compute container. Then there is the task execution. When the task execution is complete, there is another phase, a stage, we say, that basically copy all the result to the bucket. So for each task, there are 3 main phases: download, compute, upload, every time. Yeah. And again, this is somehow it's better compared to the first approach we were mentioning, but still there is a lot of duplication of data, a lot of compute time that is only used to download and upload data. And since compute is quite expensive, it's not optimal.
Gotcha. So what's the solution then? I mean, we need another fuse driver to mount these buckets, or?
Well, I mean, we don't need, but all the point we start to reasoning how we can make this better, because there are also other very tricky problems using this approach. For example, when you use just AWS S3 command line tool, copy all this file, this work maybe decently when you have a bunch of files, 1, 2, 3, 10, whatever. But It's not unusual. These compute tasks in life science pipeline are data set of thousands of files. So imagine that for each of these files, the AWS S3 command line tool need to make an authentication to verify the identity of the user. Seems it's cheap, but when you are doing this thousands of times or more than 1,000, you can find API threat limit. There are a lot of problems, so it becomes very fragile. Also, to make it possible to use the AWS S3 command line tool into container job, it's not a simple thing because you should include this into the container, but we want to use standard stock container like biocontainer. So we have this other trick to install this into the VM running the containers, but also did create also other complexity to set up the environment. And this is why generally to run Nextflow with AWS Batch, you need to create a custom VM. It's possible, but it's boring, error prone. So a lot of other tricky problems. This is why we were struggling how we can make this process more efficient, avoid the duplication of the files, avoiding to have this stop the work phase in which the task for a period just download the input data, then run the computation. Then there's another phase to upload the result. In fact, we would like to have a much straightforward approach in which the data into the object storage is directly accessible to the task, so that the data can be read on demand when it's needed. In a leads approach, in a parallel manner, and also the result can be uploaded in background while the task is running, not at the end. So we try many different things, many different approaches, many different ideas, and then we ended with this idea to implement. Well, actually, we made first other experimentation with classic fuse driver that are out there. There are plenty of fuse driver that allows you to mount a bucket into virtual machine, into a container to upload and to access directly, essentially, the data from S3 into the container. However,
a fuse driver is something that sits in a system kernel, right? Correct me if I'm wrong, and basically allows you to access, in this case, an S3 bucket as if it was a local regular disk drive.
Essentially allows you to mount just storage like a file system. So when a file that is into a bucket and have a name, you can access in the host or the container running this file like it is a local file. It's / so mount point and then the object name. And so the task have the perception that it's a local file, but behind the scene, then there is the transfer data, the download operation.
Problem solved.
Well, problem began. It's definitely a smart approach, but when we try the most common tools out there, there are Goofy or GoofyFS, Airclone or GFS for Google Cloud Storage. More or less they work, but still the performance are a bit crappy because they essentially are not designed for data pipelines, are designed for small files. So behind the scene, most of these tools, what they are doing is just taking the file, copying locally, and so then the application that is trying to access can read from the local copy. But this still open a huge problem when you have large data, because you are just shifting the copy to another layer, So when you're instead of his Nextflow doing this copy, it's just this Fuse driver doing the copy. And then there is also the problem: what happens if there is not enough stretch or temporary disk in the local container, in the local host, because this stuff is copied from remote locally. So since we need to make this work with data pipeline that can easily require some 100 gigabyte or even some terabyte for a single job, it's not easy to have that temporary storage into a cloud environment. So a lot of problem that that made us starting from a scratch implementation of a Fuse driver that was designed exactly for the problem that we are facing. Data pipelines, lifetime data pipelines with large data set, and Nextflow data pipelines, because also the Nextflow, how it works, has an impact on the design of the Fusion file system to make the two tools work in optimal manner together.
Nice. So, Jordi, you've been working on Nextflow for longer than almost anyone apart from Paolo, I guess. Can you give us an overview of the kinds of things that you can do, which Nextflow specific with this kind of file system interaction?
I think that the important thing is that when we saw the limitations of the standard Fuse drivers, we realized that we wanted to implement a new thing that it has to be easy to use. So that means from the infrastructure point of view, very easy to deploy. We wanted to avoid that you had to mount it in the host and then access from inside the container. So this is why, for example, we put the Fusion driver inside the container and transparently with Wave. So we are injecting the binary and mounting. So there is no need to do anything at the infrastructure level. So that was one first thing that we wanted to make it easy. And this is because it's run by Nextflow, so everything is done by Nextflow. Then the other problem that we were seeing with the Fuse driver when you mount at the host level, sometimes there was some inconsistency. So when a process finishes and starts the next, still the data in the backend in the S3 was not consistent. So there were some errors because there is some delay in these kind of drivers when you upload things that maybe at some point is still not there. So we saw some of these problems more, and also some problems when there was a lot of throughput, that a lot of files, big files. Then we realized that.
So there you're saying basically Nextflow had finished the job with it, and with a regular Fuse driver that we didn't know about, it would just kind of kill the instance because it was finished, but the uploads were still running. Whereas with a custom Fusion one, Nextflow and Fusion can talk to each other and make sure all the uploads finished.
The problem is that with the other drivers, sometimes there are some caches at the level of the container and the page cache that when the next starts, they may be not there yet. So this is also why we decided to have to mount Fusion at the beginning of the container when the Nextflow task starts, and unmount it at the end. So in this way, we guarantee that everything has been flushed to the disk, so that the next process will have it there in S3. Even if it's in another host or in another machine, whatever it is.
Gotcha.
And then doing that, we realized another fact that because another goal was also to remove the staging time at the beginning of the task and the stage out time at the end. So the staging, it was easy. It's what we were doing before with a normal Fuse driver, but the stage out was more complex because then the process has to run directly on top of the Fuse folder, not the Fuse driver. And this requires more complex POSIX compliant file system. But then what you get is that at the shutdown, at the end, this staging out, it's very fast. Why? Because while the process is writing a file, on the background, Fusion is uploading everything. So when the process finish, everything is there in most of the cases, because in general, at least in bioinformatics, the process, they tend to do something. So they are a bit slow because they are doing CPU. So there's plenty of time to upload things on the background. And with this, we realized that this was powerful. Why? Because we were able to decouple the local input-output of the process from the network input-output. So at the end, with Fusion, the process is always interacting with the local disk. That if it's a good disk, like an NVMe disk with a good throughput, then it's very fast. Also writing, it's reading. It will depend on your network, because first Fusion has to download the things, but writing it's very fast because it's not non-blocking. So this decouple of this network bandwidth and the local disk is what gives a lot of power that sometimes in a benchmark you cannot see, because the benchmarks are typical. You only check the throughput of the network. But if the process is doing something with the data, cannot read at the maximum speed of the network many times. So you have plenty of time to prefetch things. So with this prefetching, we also saw that because we are running with Nextflow, we can do very things that with a normal Fuse driver will never be able to do. So Nextflow knows what are the inputs of that process. So we decided, okay, we know what are the inputs. So as soon as we mount the file system inside the container, we are going to start downloading in the background these files.
Can see into the future which files are needed before the file system actually requests.
Exactly. So and this is very good, because then when the process starts reading that, it's already in the local disk. And also because we are doing this local cache in the disk, many times, if the network is faster than the process can read the data, that this in Amazon S3, it's very normal. So the data is always ready, because we are prefetching very aggressively in the future, no, in the next chunks of the file. While alternatives like the mount point of Amazon or other things, they keep the things in memory. They can prefetch only a small portion of the file because they prefetch in memory. So we can prefetch very big. So this is what it gives us in a normal situation, that the process cannot ingest the data so fast. Then it's faster than other solutions. So this kind of things is what, because we know that it's the life of the task, we can do this kind of things that improve the performance.
Very cool. I didn't realize that about the in-memory thing. Nice. And so how, Paolo, you kind of mentioned at the start, we're trying to kind of ease up the pressure on the main Nextflow head job. I can see how we're now doing that at task level, and I can see how this is maybe got some superpowers over some kind of vanilla Fuse drivers here. How is this set up from an end user kind of point of view? Like, what if I've never heard of Fusion before today, and I'm running Nextflow pipelines? How do I get started with Fusion? How do I start to get these benefits?
Dramatically simple. Like Jordi were mentioning, we want to have a seamless experience. I mean that we didn't want us to Nextflow user to configure the infrastructure for this, not even change the pipeline configuration, if not to configure and require the usage of Fusion. So essentially, basically, to use Fusion, you need to change your Nextflow configuration. You need to enable the Fusion, the use for Fusion. That means that you need to specify Fusion.enable equals true, and then to make it possible to use Fusion within the container. Basically, we are using the Wave containerization system. So you need also to enable the use of Wave. So these having to do these two components, any pipeline that read, access data over S3, for example, you are running into AWS Batch, can use Fusion without changing anything else. With an important disclaimer that the AWS Batch compute environment need to be configured with instance type that have fast local storage. That is usually the MVMe storage type. And the good news is that most of the time, this type of instance storage is available in all virtual machine. Most of the virtual machine that we use in the AWS Batch, but it's not even used by anything. This is a huge waste of computing and storage capability that are made available by AWS, because they provide this storage by default in the VM, and they don't charge for that. Instead, most people add extra ABS disks to have extra storage when there is already plenty. The point is that it's not formatted, so there is a kind of trick or an extra configuration step that you need to make into the launch template of the EC2 instance to format and mount the MVM instance storage into the EC2 virtual machine. So if you are using Nextflow manually, you have to have a bit extra setup of the AWS Batch compute environment. If you are using Seqera platform, there is just a checkbox that enables this capability and is doing everything for you.
So let me run this past you, because I didn't actually realize this myself. I've heard the term NVMe kind of mentioned a bunch of times. I've never really understood exactly what it meant. I knew it was something to do with fast disks. So normally if I spin up an instance on an EC2 instance on AWS, like you say, I choose to attach a file system like EFS or EBS. But you're saying that these are basically fast disks which are part of the EC2 instance itself and are just sort of sitting silently there unused.
Exactly.
Is that right?
It's a bit crazy, a bit obscure, the reason why they keep unformatted. But it's like this. Basically, they will give plenty of storage that if you are able to use, you just can use for free. It's included into the VM charge.
Amazing.
Also, you would notice that the EBS disk is a network disk, so it can be fast. You can increase the performance of the disk, paying, of course, but then also the bandwidth of the network, you are competing between downloading things from S3 and uploading to the EBS network storage. So also it's when you use the NVM disk in Amazon, the good thing is that this input output to the disk is not competing with the download from the network. So that's also another good thing.
Kind of a bit like having a scratch disk on a local node if you're running on an HPC.
Exactly.
Very cool. And through Wave, which we've talked about before, and we're mounting the Fusion binary in, so we can use normal Docker containers. We're just using Docker. We don't have to do anything special. So it's just basically coming down to a couple of lines of an Nextflow config file to make all this run.
Yes, indeed. We didn't want to have this horrible experience to pre-build MEI or container to use this technology. That is extremely boring and error prone. Instead, we want to have a more frictionless experience. This is why we turned this into basically an extension, a capability to add the Fusion driver on the fly into your container without rebuilding them using Wave. It is streamline all the execution, the configuration phase.
Nice.
And also the other nice news is that basically when using this technology, you don't depend anymore into the AWS S3 command line tool. So there is not anymore the need to create a custom MEI for running Nextflow with AWS Batch. Okay, maybe it's a one-time task, but still quite tricky. Not everybody has the skill to do that.
Yeah. I remember setting up my first Nextflow pipelines on AWS
bit
years ago,
horrible.
fighting with custom AMI
to
registers.
create AWS resources.
Much nicer just to click the default one and hit go.
Yeah.
Very cool. Okay, and so and the final piece of the puzzle, because this is part of this kind of Seqera ecosystem, I guess we're using Wave, so presumably you need to be set up on Seqera platform somehow to also to use Fusion. Is that right? Does the pipelines need to be running through platform?
Yeah. So if you want to use Nextflow and Fusion on Seqera platform, there is just that simple configuration setting when you create the compute environment in the Seqera platform and then launch the pipeline. There's almost anything to do other than setting the feature and the configuration. If you want to use Fusion with Nextflow command line, you can do that, modify the configuration file, and then you need to also provide your Seqera platform access token into the Nextflow configuration file. But this is a free account. It does not require that you need to then work into Seqera platform and pay for something.
Okay, nice. The NVMe thing was one of the things I wanted to bring up because I've heard it talked about before and I thought it was interesting. So we've covered what that is and why it matters. Something else I've heard come up a bunch of times. Fusion has been around for a little while, right? And there's a Fusion V1 and then there was a Fusion V2. Could you sort of talk me through the history of Fusion and what those milestones meant?
Maybe we should have changed name. And so for this, because creates some overlap and some confusion. Essentially, what we call Fusion V1, version 1 was the first experimentation on the idea to use a fuse driver using stock or popular command line tools. Originally, we were using GoofyFS, but it was nothing more than mounting a GoofyFS fuse driver into the host and then from the host into the container. So the classical way to use a fuse driver, and that did not scale as we were expecting. I'm not even expecting because it's not a magic solution just using a fuse driver to gain this capability. So what we were mentioning before, you can do that, but does not scale. Fusion version 2 is our own solution designed from scratch to work at scale with Nextflow. So this is very important that are completely unrelated somehow project, if not the common idea to mount the bucket into the file system.
Okay, so if people have used Fusion V1 and kind of figured, I tried it, it didn't make much difference, then get rid of that idea, come back and try again. And I guess also, I mean, people are often familiar with these other fuse drivers like Mount Point and kind of rclone and stuff. So I guess also even if you've used those before, then it's still worth trying Fusion because you might have quite different results. Okay. Jordi, Paolo, who's going to show me? Have you got some results? I'm not going to just take your word for it. You've got to prove to me that Fusion is fast and amazing.
Yeah, I think very important points because at the end we are not doing this just to engineering challenge, but because we want to provide some benefit. This is the most important thing. And when you use cloud, benefit means spending less money.
You're not going to tell me that you don't.
More efficient computing.
I'm sure you enjoy the engineering challenge as well, though.
Oh yeah, it's a pleasure. We cannot live with that.
So I've got a slide here.
Yeah,
this is from your talk in the summit, right?
Yeah, exactly. Basically to show the benefit of Fusion, we compare RNSC pipeline using a real data set that is available in F-Core RNSC that has full profile, comparing an execution with just using S3, AWS S3, so AWS batch plus AWS S3 as a scratch work directory, then using AWS batch with AWS FSx, so a shared file system into the cloud, is quite efficient way to manage this, even though there are some also tricky things happening with that. And then using AWS Batch with Fusion VT would do version 2. So yeah, I think it's quite self-explanatory. Also, it's important for this we use on-demand instances to have more predictable number to avoid spot interruption that could alter the benchmark. This is all a bit reflect, maybe reflect also in the cost. But apart this, so basically when you use FSX, you have much faster computation for all the reason we were saying before. It's a shard file system, so there is not anymore the each task download all the data before starting and then upload back the result. So we remove a lot of compute time only dedicated to transfer the data. And also the file system is more efficient, so we have basically we double the throughput of the computation is twice faster compared to in CPU hour compared to only use S3. And the very good thing that basically with Fusion, we can achieve the same result, even slightly faster into this benchmark. So Fusion allows to achieve the same performance like a shard system for highly optimized like cluster for effects, just using mount into this container and transferring the data on the fly using the Fusion driver into the container.
So anyone listening to the audio here, this is kind of the first of two plots, and it's showing CPU hours for RNA-seq pipeline, and it's gone from 800-ish for AWS 3, and then 2.14 times faster with FSX, and 2.22 times faster with Fusion V2. So now under 400 CPU hours instead. Very cool. Yeah,
exactly. So basically, just you want to comment this?
Yeah, I will add that we don't represent here, but on top of this, that we are comparable to using a parallel file system. It's easier to use at the level of infrastructure. And also that with Fusion, we haven't said, because it's for us it's obvious, but what you get at the end, it's a normal file on S3. So your files are on S3. While if you're using other alternative like FSX, you still need to copy the things from that file system, FSX, to S3 at the end. So that's also an important feature of Fusion.
Yeah, indeed. Exactly. And there is so these are the same
S3 is generally
but we remove a lot of machinery because AWS FSX is a separate service. You need to operate independently. You need to set up, and also there is this problem that you allocate in a fixed manner. So when you create a FSX file system, you need to say, I want to use 1 petabyte, 2 petabyte, whatever. If it's too big, you are just burning money because you pay per allocation, not on use, apart than the use. If you allocate too small, then your pipeline will run out of storage and is ugly. So
yeah, that's those two really key points then, because we want to be using S3 because S3 is like the cheapest data storage on AWS. It's universal, it's supported everywhere, it's just generally great. So we're using S3 basically with that transparently here, and also it's infinitely scalable, and you only pay as you go with Fusion.
Exactly. Cool. And then the impact on the cost is dramatic. There is the second chart that shows the difference in cost of the same pipeline execution. Also, in this chart, we include the expense to keep the data into the storage for 1 month. Because you need to keep the result into your storage. You cannot throw away. So basically, just using AWS Batch S3, the cost was for 1 month $124. With FSX, nearly $300 to $293, and Fusion only $69. So even cheaper than S3. This is quite surprisingly, because we said that Fusion is a Fuse driver on top, technology on top, S3. So at the beginning, you would expect, we were expecting as well, that will cost the same. Instead, was even cheaper. And this, to understand this effect, we need to struggle a bit, and then we realized that this was coming out by the fact that when you use Fusion, basically Nextflow is able to use the usual way to create symbolic link across files of the pipeline. It is reduce a lot the data duplication that there is your pipeline. So at the end of the day, when you use Fusion, Nextflow is able to create symbolic link, removing the need to create duplicate of the same file during the pipeline execution, and resulting in less usage of the storage in the cloud in S3, decreasing the total cost of the pipeline execution.
Nice. Should never admit to accidentally coming through up with breakthroughs, Paolo. Fantastic. So huge drop in price for Fusion V2.
Yeah.
And then this is then what you're talking about. This next one is about
storage
usage.
Exactly. The second slide, because it was so surprisingly, we ran a separate benchmark only to measure this and to double check. Indeed, so there is a huge benefit of just by the fact that the ability to use symbolic link and removal data duplication decrease a lot the amount of data, the final amount of data created by the pipeline. So RNA-seq produce 90% less data when you use Fusion compared to just S3, and to Sarek, that there's a huge difference when you use Fusion. Basically, the pipeline produce 61% less data compared to S3. So there is an enormous impact on the data created by the pipeline and the final cost.
I mean, that's massive. Yeah, 61% less. So, yeah, it's huge. Very cool. Okay. So then that's kind of speed and cost. I don't know what did you want to talk about any other kind of benchmark results, or as this slide you flicked up earlier?
I think these are the most important figure is also what I want to stress again, that the big benefit is the ability to remove the need for a separate storage system that can be FSX that you need to operate and maintain independently. And a part of the cost, there is enormous benefit that not only we improve the efficiency of the task, but we only remove the need to copy the data, the copy of the data made by Nextflow, that as it happened when you use FSX. So it's true that FSX is fast and efficient, but a part of the problem of the cost remains the problem that from Nextflow point of view, when a piece of data is S3 and you work on FSX, Nextflow need to copy the data on the shared file system, and then the task can use the data from the shared file system. So even using Nextflow with FSX, there is a lot of data transfer made by Nextflow, a job that is highly inefficient.
Gotcha. So Fusion is faster, cheaper. Is there anything that Fusion enables which is kind of novel? Like, Jordi, I'm thinking a little bit about, you were talking to me recently about being able to pull in kind of multiple different regions of AWS with Fusion into one environment. Is that right?
Yeah, if it's something, at the end, Fusion, it's a multi-cloud or multi-storage S3 driver or equivalents. Like we have Azure, we have Google Storage. And as far as you provide the credentials to access that places, you can pull from everywhere. You can, as soon as you mount Fusion, you have access to all of the clouds that your credentials give access. Or for example, you can run one thing in Azure, and if you are using something from a public bucket in S3, it will work. So for Fusion, it's agnostic in this. It's something that we want to work in this year to integrate better with Nextflow, so to make even possible these kind of things. But this is one of the benefits. Also, another benefit is if you think in regions. So with Lustre, you have to decide in which zone of your region you set up the file system. While with Fusion, because we are using S3, that it's always replicating all the zones in the region, we don't have any problem. We can use things in this. The compute can use different zones in the region without any problem and without any extra cost.
I mean, this seems like a huge thing to me because, I mean, we've been hearing the promise of a cloud for years about take your compute to the data and everything, but still, I'm sure many people listening to the podcast will have spent hours or days kind of downloading huge public data sets. You've got things like the TCGA, the Cancer Genome Archive, or reference genomes, all kinds of things which are stored in cloud buckets, and they could, like you say, could be on Google, could be on Azure, could be on AWS. So now if you're using Fusion, there's a whole extra step of kind of manually prefetching data. You can just plug it in, and it's just going to be mounted there as a directory alongside your own compute and your own data.
Yeah.
Huge. That's very cool. Is there anything else that can do that out of curiosity? Are there any other tools, or is Fusion the only one you know of? Like, does mount point and stuff let you do that?
Well, the thing of being like you only mount one mount point and you have access to multiple clouds, I haven't seen any. So in general, you have the Fuse driver for each different kind of storage, or for example, our clone has support for many storage, but you have to mount a different mount point for each.
Very cool. So kind of continuing along those lines, if I'm not running my compute on the cloud, I don't have cloud, I haven't put in my credit card details to AWS just yet. I'm running on my HPC, but I want to access data on the cloud. Can I use Fusion on my HPC yet? Is that possible, so that I can access cloud data in this way?
Right now, I would say that we are moving in the direction to also bring the benefits of Fusion in the HPC world. Right now, the benefits it's in the HPC. It's more if you have all your data in some kind of block storage or local block storage. So if it's an S3 compatible one, you can also use Fusion.
Okay, but so it works locally on HPC if you have like MinIO or something like that, like an S3
exactly
on HPC.
Cool. Or Ceph, for example. So the only thing is that we have to explore a way to like that you are able to combine, so to use things from your normal share file system and things from the block storage. But this is something that I'm sure that this year we will implement and integrate better with Nextflow, because it's not that complex. We already have all these things. It's just a matter that we need to just test that everything works well, because right now we have been very focused mainly in Amazon, so everything goes very fast and very well in Amazon, but we have to be sure that also in Azure and Google that we already support, but we want to improve the performance there, and then we also want to improve the performance in different HPC setups.
Nice. And can you give us a taste of anything else that's sort of going to be coming up for Fusion in 2024?
I will say that the first thing, that the next thing is to make it as fast as possible in Azure and in Google, that are the other two main clouds. And then all these things about HPC support, because also we didn't say, but Fusion, it's also possible to run it with Singularity or UptimeNet. So it's not only a Docker thing, so you can use in a more typical HPC scenario. And then some improvements because of the Data Studios effort, that that is going on in Seqera. So to also be able in an interactive session use Fusion more for the daily things that you do in an interactive notebook or Fire Studio, Jupyter Lab, things like this. So also this changes a bit some of the benefits of how we have to adapt Fusion, but still you get all the benefit of that at the end everything it's a POSIX path and everything is on S3. You don't need to keep copying things from one storage to S3 and downloading and uploading, so it will be more transparent.
Is there anything further? Can we go any further with Nextflow? Have we kind of exhausted how much we can optimize performance with kind of Nextflow tricks, or is there anything else up your sleeve?
No, sure, there is many room for improvement. So, for example, one thing that we want to do is, given that we know which are the intermediate files of the process, when a process is defined, you know what are the inputs and what are the outputs. So the other files are intermediate files that if you use a Scratch equal true, you don't want them. Right now, because we use a Scratch equal false, we are also storing that files to the S3. But what we want is to try to reduce and do not upload these files if it's not strictly necessary. So if there is enough space in our local disk, we will try to avoid uploading unnecessary files to S3. So this can be, for in Amazon that it's very fast S3, I don't expect much benefit. But in other setups, more HPC setup that maybe or if you run from your laptop and the S3 it's remote, so then this will make a big difference to try to minimize the amount of data that you upload. Also, we want to try to test to upload things compress on the fly and decompress on the flies. So we want to experiment trying to reduce the volume that we upload to the S3 or the object.
Cool. So you might have to update that slide again, Paolo, about 61% for Sirec. We can keep pushing it up to 70% less data storage.
Yeah. In fact, I was expecting that with Fusion, the pipelines had to use more storage, but it was the opposite.
Very cool. And Paolo, is there anything we can kind of do with, Fusion is now acting as a gatekeeper for file access here. Is there anything we can kind of use to I'm thinking about security and stuff like that. Is there anything clever we can do here?
So an idea on which we are brainstorming the minute that since basically exactly Fusion is a proxy, the intermediate access of the data between the task and the storage. One thing that we are thinking that we can use basically to segregate the access of the task only on the declared path where it expected to work, so that this brings security, so that a malicious tool or command cannot escape the context where it is supposed to work, but also fit better the immutability model on Nextflow, in which one task is expected to work only in its own work directory, not in other path. And also using the same approach, we can add some extra layer of security on the network, maybe preventing that a task try to open unexpected network connection, this kind of stuff. So this is a kind of idea around which we are thinking to make Fusion also a kind of security umbrella around the task computed by the pipeline.
Very, very cool. I like the idea of that you never. I remember talking to HPC admins who were setting up Nextflow, and once the Nextflow task is running, you never really you can look at the code, but you never really know what it's going to do. So anything it can sit in the middle and actually validate expectations between the Nextflow pipeline and the binary code itself is very cool. Looking forward to that. Maybe we'll have you guys back on in a few months and see what progress we make in 2024.
Yeah.
Very nice. And so if people are interested in Fusion, you can go to the Seqera website, right? That's seqera.io/Fusion over here, and you can kind of read a bit more about what it is and how it works and stuff. And there's documentation for it as well. And I guess if you're looking for help, then also we've got I'll flag the new community forum for Seqera as well. So community.seqera.io, and there's a section down here dedicated for Fusion. So any questions about Fusion, even if it's just you're interested and you want to know more about how it works, that's how to get a hold of Jordi. Great stuff. All right. Anything else you'd like to leave us with regarding to Fusion? Any final thoughts, or are you happy?
I think the final message is that Fusion is not yet another Fuse driver, but is a technology designed to work with Nextflow to enable the scalability data pipelines, really designed to allow to handle very big data set. This is common in this field, for which is very difficult that you can achieve with other solutions.
Great stuff. Okay, just before I go, I'm going to quickly touch on a couple of recent updates in the community, just more generally kind of podcast news. On the Nextflow blog, Ben, a regular on this podcast, has put out a new blog entry about optimizing Nextflow for HPC and cloud at scale, which is really nice. Actually, kind of a very practical walkthrough of some of the common things hit when real life scenarios with Nextflow. So well worth a read. I recommend that on the Nextflow blog. The other thing I was going to flag is over on the NF Core community, we've got our next hackathon is now looming on the horizon. The next hackathon will be in March, and it's going to be an online hackathon, this one, but we're doing local distributed sites. So March 18th to March 20th, and we've got, I think there's 14 different local sites already signed up all around the world, from Argentina to the UK to Brazil. There's lots here. I have a feeling we've got a couple more in the works, so hopefully this list will get a bit longer and you've got maybe a day or two to quietly sneak in a new site if you're interested. But please go and have a look and sign up and join us over in NF Core. I think we're going to have a lot of fun there. Otherwise, all that's left for me to say is a huge thank you, Paolo and Jordi, for joining me today. It's been a pleasure. As is always the case, I've learned, even though I feel like by now I should know everything there is to know about Fusion, but I still learn more when I'm talking to you both. So many
was
thanks
a great
for your time.
pleasure as well. It was actually complex stuff, so it's important to find a space to talk, to clarify these things.
Absolutely, yeah. And Jordi, congratulations on your first podcast, and I hope to have you back another time, talk about some other interesting stuff we're building.
Sure.
Great stuff.
Thank you.
Thanks very much, everyone. Thanks for listening.
Bye.
Thank you.